Alright, chapter 4.5. Before I introduce the main topic, or I guess term of this subchapter, I'm going to give you a little thought problem. Or I guess I don't know. A little problem for you to think about. So let's look at these two beakers that I've drawn here very crudely for you. You have a beaker of 50 milliliters of water. Let's say both of them are filled with 50 milliliters of water. And these little black dots symbolize a gram. Each dot is 1 gram of lead nitrates. Just an example. So we need to find a way to express the amount of lead nitrates in comparison to the amount of water. We're trying to say what is the concentration of lead nitrates in the solution. And that's where the term molarity comes in. Molarity is basically the concept of expressing the concentration of solution as the number of moles of solute. And as you know, a solute is the thing that is being dissolved, and a solvent is the thing that is doing the dissolving. Now, molarity can be a little bit confusing, just in terms of the name. Molarity and moles. So the way that scientists kind of discern them is that molarity is symbolized as a capital M, and moles are a lowercase m. So anyway, the solution of molarity, or the formula, is moles of solute over volume of solution in liters. So typically this is just written out as m over v. And that is probably the most prevalent conversion that you're ever going to be using in chemistry. Like, this is the main thing that you're going to be doing in chemistry, and it becomes so easy. So I'm going to start you off with a little problem. All right. Yash put 4 moles of arsenic in Miss Hart's coffee as she gave him a 0 on the Formlab for cheating. Well, don't cheat on your Formlab, y'all. What is the molarity of arsenic in Miss Hart's coffee of half a liter? So, we know that there are 4 moles of solute and half a liter of solvent. Now, generally, when you're doing these calculations, you need to do stoichiometry. Here, I've given the easiest possible numbers, moles over liters. Moles and liters. And there's not going to be any conversions required, but there will be a lot of the time, most of the time, if not all the time, especially on the AP exam. But we're going to start simple. So we know that the formula for molarity, capital M, equals M of solute over liters of solvent. Those look the same. So, we know that arsenic is the solute, and the coffee is the solvent. So we just plug in our numbers, and we get 4 mole AS, because that is what arsenic is, AS, and 0.5 liters coffee. And then we plug the numbers in, and we solve, and we get 2 moles. We get 2 molarity of arsenic. And that's all. Now, on to the next problem. Alright, on to a slightly harder problem. If Nikhil eats 23.4 grams of bananas, and we're going to assume all of this banana is potassium, just a potassium in a little, a little peel, a potassium peel. What is the molarity of potassium in his belly of 4,324 milliliters? So let's start with what we're given. 23.4 grams of bananas, or potassium, and 4,324 milliliters of solvent. And we're just going to assume his belly is just full of stomach acid. So it's 4,324 milliliters of stomach acid. So now we have to convert potassium, grams of potassium, to moles of potassium. And we know this through basic stoichiometry. So 23.4 G potassium. Oh wait, that's K. And I also have the little PR table information on it. You'll be given the PR table for everything you're doing in chem, unless Miss Hart decides to be a masochist that year. But basically, you're always going to be given a PR table. Anyway, 23.4 grams of potassium times 1 mole of potassium over 39.08. Now this should just be second nature to you at some point, but it may still be hard for you. So then you multiply these together and the units cancel. Grams cancels and we just have moles of potassium. So if you calculate this, you'll get 0.598 moles of potassium. And now we want to put this in molarity, which we know is capital M equals lowercase m over V. Small problem, our V is in the wrong units. It's in milliliters. But we already know that 1 liter is 1,000 milliliters. So all we're going to do is just say 4,324 divided by 1,000 is the amount of liters you have, which is just 4.324. So now we're going to divide by our solvent, 4.324 liters stomach acid. And we're going to get our value, which is our final molarity. And that is going to be 0.136 capital M. Always remember the capital M because it will not look right. Capital M potassium. Now it's always very important to put your units in. I got a lot of points off in the class for not putting units on tests and quizzes. A lot on quizzes. Just make sure you always put your units. That's going to be my reminder. So yeah, the molarity of potassium in Nikhil's belly is 0.136 molares or molarities. I don't know. Moles over liters. Yeah, that's all.